Welcome to the lesson on revisiting rational and irrational numbers. At the end of this lesson, you will be able to distinguish between rational and irrational numbers. You will also be able to prove theorems related to rational and irrational numbers. There is a big commotion at the Rational Numbers Club. The club is exclusively for rational numbers, but it appears some trespassers have gotten inside. It seems the rational numbers have identified the trespassers as irrational numbers, but the trespassers insist they too are rational numbers. This debate is really getting heated. Well, the law of Numberland has taken its course and the accused trespassers have been summoned in court. The accused still insist they are rational numbers. Here is Mr. Public Prosecutor, who believes that the accused are irrational and not rational numbers. Let us see how he presents his case. Mr. Public Prosecutor is kind enough to present his notes on this screen for all of us to see. Mr. Public Prosecutor is starting by introducing the two parties to the case. A number is called rational if it can be written in the form P upon Q, where P and Q are integers and Q is not equal to 0. A number is called irrational if it cannot be written in the form of P upon Q, where P and Q are integers and Q is not equal to 0. The accused still stand by their claim of being rational numbers, but Mr. Public Prosecutor is all set to begin his argument. Let us hear what he has to say. The theorem Mr. Public Prosecutor wants to present states that if a prime number P divides Q square, then P also divides Q, where Q is a positive integer.
So students, as you have watched the video, in that video the rational numbers and the irrational number, it is a funny video. The irrational numbers are claiming that we are rational numbers and they are going to prove it. So let's see how they can prove it. Okay. So these numbers, irrational numbers, they are claiming that they are the rational numbers. So let us assume that root 2 is a rational number. Rational number. So we have assumed that root 2 is a rational number. So any rational number, if it is a rational number, any rational number can be represented at a by b form, numerator upon denominator. Okay, because we have assumed that it is a rational number, where a and b both are integers and co-prime numbers. Okay, so a and b are integers and they are the co-prime numbers. So let us discuss what are co-prime numbers. Okay, so what are co-prime numbers? Co-prime numbers are those numbers which has a factor only a 1. So let us take an example, 21 upon 14. Are these numbers are the co-prime number? No, because they are divided by 7. 7 3s are, 7 2s are. Now these numbers are co-prime number because they are not divided by any number apart from 1. Let us take an example, 7 upon 5. Are these numbers of co-prime number? Yes, it has. These numbers are the co-prime numbers because they are not divided by any number. Let us take an example, 35 upon 21. These numbers are again divided by 7, 7 5s or 7 3s are. Now these numbers are the co-prime numbers. So you got the idea what are co-prime numbers. Co-prime numbers are those numbers which have a factor only of 1, because these numbers are only divided by 1. These numbers are only divided by 1. So we have assumed that a and b are integers and the co-prime numbers. It means that a and b are not divided by any number. They don't have any other factor other than the 1. Okay, so now we have to square it on squaring both sides. Okay, so what is the square of root 2? Root 2 square equals to a square upon b square. Root 2 square is 2 is equals to a square upon b square. When this b square is shifted to this side, it becomes multiplier. So 2b square equals to a square. So what does this implies? It implies that when this 2 will shift to this side, it will divide it. So it implies that a square is divided by 2. If a square is divided by 2, a is also divided by 2. Okay, we have seen in the previous theorem that if a square is divided by 2, a is also divided by 2. Then this is the equation number 1. Okay, what is equation number 1? Equation number says that a is divided by 2. It means that a has a factor of 2. Okay, now let us assume let a equals to 2c. Now again square it on squaring both sides. What is the square of a square? 2. What is the square of 2 and square of c? So a square equals to square of 2 is 4 and square of c is c square. So put this equation in, name it as equation number 8. So you have to put this equation in a. What is equation number 8? 2b square equals to a square. So 2b square equals to, in place of a square we have to substitute 4c square. So when 2 will shift to this side, so it becomes b square equals to 4c square upon 2, because when it is shifted to this side it will divided it. So b square equals to 2 ones are 2 twos are, b square equals to 2c square. So what does it implies? It implies that b square is divided by 2. B square is divided by 2. If b square is divided by 2, b is also divided by 2. Okay, this is equation number 2. So from 1 it indicates that a is divided by 2. From 2 it indicates that b is divided by 2. From 1 and 2. From 1 and 2, a and b both are divided by 2. So what we have assumed? We have assumed that a and b are the integers and co-prime numbers. What are co-prime numbers? Co-prime numbers are numbers which are not divided by any number. But now here we have proved that a and b both are divided by 2. It means that our assumption that it is a rational number is wrong. So 100% root 2 is a irrational number.